In this video, I'm going to discuss binomial distribution. Binomial in probability begins with an action or a trial having only two possible outcomes. The two and only two possible results of the action are success and failure. So, suppose a spinner has three blue edges and one white edge, like the one that we have here. If we call the blue result a success and the white results a failure, then we have what we call a binomial experiment. So here's an example. Let the random variable x be the number of successes or blue results. So because this is a discrete random variable, it can take 0, 1, 2, or 3. What I mean here is the number of blue results. If we spin the spinner 3 times, we can end up with 0 blue results, 1 blue result, 2 blue results, or 3 blue results. So x can take these values. So like I said, if we spin the spinner 3 times, we end up with this results, which is represented here in tree diagram. So you have the first spin, the second spin, and the third spin. So suppose we want to calculate the probabilities of these outcomes. So the probability that we don't have a blue result, or probability that x is equals to 0, will be a quarter to power 3. The probability that we have one blue result, that means x is equals to 1, will be 3 multiplied by 3 over 4 multiplied by a quarter squared. And then probability that we have two blue results will be 3 multiplied by 3 over 4 to the power of 2 multiplied by a quarter. The probability that we have 3 blue results will be 3 over 4 to power 3. So by inspection, we can see a few things here. So you can note that the number of ways of getting one success or one blue result in 3 trials is 3 choose 1. Now, when I talk about the number of ways, if I can just go back to this diagram, this is what I mean. So these are the number of ways of getting that. So back here, what I'm saying is the number of ways of getting one success or one blue result is 3 choose 1. And we know that 3 choose 1 is equal to 3. And then we are also saying that the number of ways of getting 2 successes or 2 blue results is 3 choose 2. And again, 3 choose 2 is equal to 3. And that's exactly what you can see here. Those are the number of ways of getting that. So we can notice that, and we can actually generalize this and say that the probability of getting x successes, which is right here, below here, will be equal to 3 choose x multiplied by 3 over 4 to power x multiplied by a quarter to power 3 minus x, for that particular example that we just looked at. So this is actually a general formula that we can use to find each of those probabilities that we did in the previous page. So what you are saying here is, and this is very important, these are actually characteristics of a binomial experiment. There must be a fixed number of trials. So fixed number of trials Each trial has to be independent. Um, each trial has only two possible outcomes, success or failure, and the probability of success remains the same. Remember, in each of the trials we did in the previous example, the probability of success remained the same. And if if those conditions are met, then we have a binomial experiment. And we can say that the discrete random variable x is distributed binomially with parameters n and p. Or you can say x follows a binomial distribution with parameters n and p. And the probability of success, so if those conditions are met, the probability of x successes in an experiment in n independent trials is given by the formula probability x is equals to x will be equal to that. Now this formula here is in your formula booklet. This formula here is in your formula booklet. That's very, very, very important. Where n is the number of trials, x is the number of successes among n trials, p is the probability of success, and q is the probability of failure. Now, remember, relationship between p and q, p is equals to p is just equal to the probability of success, but q is equals to 1 minus p. So just keep that in mind, because one is a complement of each other, right? So if the probability of success is, for example, 3/4, the probability of failure will be a quarter. Okay, this is also very important. The mean and standard deviation. So the mean and standard deviation of a binomial distribution are given below. Remember, the mean is same as the expected value, which is equal to that, and the variance is equal to that. This formula again are in our formula booklets, right? So you don't have to cram them, you just need to know how to use them. Like I said previously, a binomial distribution is a discrete distribution. Since x, the variable, is the number of successes in n trials, it can only take the numbers 0, 1, 2, 3, and so on. But this is a finite, all right? It stops after some point. We're not saying here that this goes to infinity. No, no, no. It stops at some point. If you have 4 trials, we'll end up with 0, 1, 2, 3, 4. If you have 6 trials, you'll end up 0, 1, 2, 3, up to 6. So this is a finite. Okay? We're not saying this goes to infinity. All right. So I'm going to look at the first example. In an inspection scheme, a sample of 10 items is selected at random from a large batch, and the number of defective items is noted. If the number of defective items is less than 2, the batch is accepted. Data collected over the year shows that the proportion of defective items in a batch is 2%. Write down an expression for the probability that a batch is accepted. So, first thing we can see here is the probability of success here is 0.02. So we need to write down what it's being considered here. So we'll say that let x be the random variable that represents the number of defective items in in the sample. Okay. And from the information that we have in this question, they're saying that the batch is accepted when x is less than 2, which means when x is equals to 0, or x is equals to 1. Anyway, so we have that, but before we do anything, we need to write this distribution in this form. We know that x follows a binomial distribution with parameters 10 and 0.02. All this information is in the question. So what we want is the probability that x is less than 2, and you're saying this is the same as probability x is equals to 0 plus probability x is equals to 1. Now, what I'm going to do here is to use the formula from the formula booklet that I showed you in the previous page. So that will be 10 choose 0, 0.02 to the power of 0, multiplied by 0.98 to the power of 10, plus 10 choose 1, 0.02 to the power of 1, multiplied by 0.98 to the power of 9. If you plug this in your calculator, you'll end up with 0.984. And that's it. Okay, number 2, x is the random variable number of success obtained when you roll dice 7 times. So I'm just going to highlight that. All right. So identify with the reasons the distribution followed by x and state clearly its parameters. So the first thing that you're going to do here in A is to check if conditions for a binomial distribution are met. Now, we can say that each time the dice is rolled, the probability of obtaining a 6 is constant. So that's one condition that is clear in this question. So each time so that's one. Another thing that we can write down based on the information that are given is each outcome is independent of the previous one. All right. So because you're rolling a die 7 times, each of those trials is independent. So each outcome is independent of the previous one, which is very important. Right? So probability of obtaining a 6 is constant. So we can say this is a binomial experiment. So let's move on to B. So probability that x is equals to 3. Now remember, this distribution here, it's a binomial distribution. So before I can start working out B, I may just want to write this. X follows binomial distribution with parameters. The die is rolled 7 times. The probability of success in each case is a sixth. Okay, so once you've written that statement, we can go ahead and work out the probabilities. So probability that x is equals to 3 can be worked out actually using your calculator. So this time round, you can just plug it in your calculator, and I'll show you how to do it. So if you go on your calculator and go to second, actually looking for its distribution, and scroll down to binomial here, binomial probability distribution function, switch in binomial PDF, and then the number of trials is 7. Probability of success is a sixth. And what we want is x is equals to 3. So plug in 3 and then just press that. You should be able to get your answer, which will be 0.0781. And then say probability that x is less than or equal to 3. You can as well find that by using your calculator. So now, because this is cumulative distribution of those probabilities, so you'll go under the same window, but scroll down to binomial cumulative distribution function. That's what you want, cumulative probabilities. Number of trials is the same. Probability of success is the same. And then x value is just 3. So these are cumulative probabilities. If you press enter, you'll end up with the answer that you want, 0.982. Next question. In binomial distribution, mod, just like when we looked at discrete random variables, mod is the largest value of x for which the probability distribution function has a maximum. The median is the smallest value of x for which the cumulative distribution function of x is more than 0.5. If there's a value of x such that the cumulative distribution function of x is equals to 0.5, then the median is the mean or average of this value and the next largest value of x. So we discuss all these things when we're looking at discrete random variables. So it's the same process. Now, what I'm going to do here is I'm going to work out number 3 using a calculator, and I'll show you how you'll do it. Now, the values that x can take here, because we have 4 trials, the values that x can take are 0, 1, 2, 3, and 4. So what I'll do is go to start, edit. So in list 1, I'll plug in the values that x can take. So 0, 1, 2, 3, and 4. Great. Now, what I'm going to do in list 2, I'll plug in probability distribution, the probabilities. So the probabilities of each of these values, I'll plug them in list 2. In list 3, I'll plug in the cumulative probabilities. That way, I can use list 2 to find the mod and list 3 to find the median. Hope that makes sense.